Hey everyone, this is lesson 28 and it's about measuring time and elapsed time. So this is a topic in math that's really important, really applicable to everyday life. You will need to understand telling time, measuring time, whether we're talking about small units of time like minutes, hours, or longer periods of time like years, decades, centuries. So this is really important stuff, very applicable to everyday life. As we move forward and take a look at your learning targets, there are a lot of specific ones, small, but very specific and important. Learning targets are telling time on an analog clock, using AM and PM when starting the time of day, okay, that's not supposed to say starting. It's stating the time of day. So, being specific about we're talking about 8 o'clock in the morning or 8 o'clock at night, AM, PM. Identifying the relationship between years, decades, and millennia. Distinguish between a common year and a leap year. And then reading a calendar. Oh, solving elapsed time problems. These tend to be like kind of the most difficult. They're kind of hard to wrap your head around sometimes. So we'll do a little practice with that as well. Here's just a little bit of notes. Things that you should know. There are 365 days in a common year. But please note that every fourth year is a leap year and there are 366 days. So this isn't stated on here, but every fourth year there's an extra day and that falls in February. So every fourth year there is a February 29th. Otherwise, February always ends on February 28th. Every 4 years, there's a February 29th. And lo and behold, 2020, it would be 2020 that would have an extra day, but 2020 was a leap year, or is a leap year, I should say, because we're still in 2020. So then, according to this, every fourth year, we won't have one again now until 2024. A couple more things: 12 months in a year, 7 days in 1 week, 24 hours in a day, 60 minutes in an hour, 60 seconds in a minute. Those are all things that we should know at this point. Little bit more advanced ones, there are 10 years in 1 decade. Looking at these parts of these words, this is really important. Deca means 10 typically. So 10 years in a decade, 100 years in a century, again, cent usually applies to 100. And then 1,000 years in a millennium. So mil, again, that preface mil applies to 1,000. This first example here, a century is how many decades? So a century, decades, these are 2 vocabulary words. I just scrolled past to answer that. I was going to say pause this video and solve, but there's nothing you really need to solve on paper here. 10 years are in a decade, and I know that 10 decades are in a century. A century is 100. So 10 decades in a century. The answer is 10. Example 2, taking a look at this calendar. According to this calendar, June 8th, 2014 is what day of the week? So just understanding how to read a calendar. That is my anniversary, not 2014, but my anniversary day. It's a good day. So June 8th. So here we go, June 2014. We're looking for the 8th. Right there. Sunday. So what day of the week? Sunday. Sunday, again, by now, you should be really comfortable with reading a calendar, but just to review, typically on a calendar, when you're looking at one, Sunday is the first day of the week that falls. I literally have like 4 calendars in front of me right now. Look at this. This is my lesson plan. As we move towards hybrid or distance learning, here's my idea of lesson plans. It's kind of a crazy mess, but take a look here on this calendar. Sunday, first day of the week. Okay. Digital and analog time. As we move more and more towards a technological future, we don't really look at these analog clocks too much anymore. Typically, just in school classrooms or like doctor's offices. We don't really use them all that often anymore, but still a super important skill to know and understand. More and more, I think, because we are getting away from using them, students aren't very comfortable with reading them because they don't have to. Everything is digital now. Everything is just right there for you. So just really getting comfortable, understanding how to tell time if we're looking at an analog clock like this. A couple more important notes. AM and PM. Elapsed time is talking about the amount of time between the starting and ending of an event like this. A clock shows the time that Rick's first morning class ended. He woke up 2 hours before this time. His lunch period begins 3 hours after this time. So what time did Rick wake up? I don't know about you, but in problems like this where they state a lot of stuff, I literally have to stop and go back and reread to really make sure I understand what they're asking. So what time did Rick wake up? It says, this clock shows what time his morning class ended. He woke up 2 hours before this time. So my first step in this is going to be identifying what time does this say exactly, and then I need to back that up 2 hours. So as I'm looking at this, I can see that the clock says that it's 9:05. If I back that up 2 hours, Rick woke up at 7:05. I'm not feeling the need to write this in. I might change my mind as we continue to move through the slides, but 7:05. What time does Rick's lunch period start? So going back to reread again, his lunch period begins 3 hours after this time. So going back again, identifying that right here, I don't know, I guess I'm going to change my mind. Right here, this time says 9:05. Sorry about that. All right, there we go. So I've identified that this clock says that it's 9:05 a.m. I knew that it was a.m. because we're talking about morning classes, right? So 9:05 a.m., he woke up 2 hours earlier than that, which means he woke up at 7:05 a.m. And then what time does his lunch period start? 12:05 p.m. This is really, really important that you identify any time around lunch, midday, then it switches to p.m. If you said 12:05 a.m., that would be like middle of the night. Let's take a look at this example here. Raven and her friends attended a movie that was 2 hours and 5 minutes long and ended at 9:20 p.m. What time did the movie begin? There are a couple ways to think about this problem, but really what you need to do, what some people find difficult about these is that it's not an equation. Really, like you can't stack these numbers on top of each other. You can't take 9:20 and take away 2 hours and 5 minutes easily. I mean, there's a way if you know how to set it up correctly. But really, the most basic way of solving these is starting with the time you're given and either move forward or move back in time. Just kind of thinking about it or drawing it out or whatever method works for your brain to solve. So for me, I would just talk through how my brain would think about this. I know that the movie ended at 9:20 p.m. I'm going to start with the 2 hours. I know that the movie was 2 hours and 5 minutes long, but if I take 9:20 p.m. and back it up 2 hours, I know that now I'm at 7:20 p.m. And then the movie wasn't just 2 hours, it was 2 hours and 5 minutes. So now I have to back up 5 more minutes. So instead of being at 7:20 p.m., I'm at 7:15 p.m. And that's what time the movie started, 7:15 p.m. In dealing with any problems about time, AM and PM, those are your label, and it's really important